Hello and welcome to our webinar, ASD Engineering Solutions for Special Applications. In this webinar, we will be talking about two special projects we did, a prison application and a museum application. If you have any questions, please post them in the chat and we shall try and answer them during the break and at the end of the webinar or by email. Please switch off your microphones and cameras now to avoid disturbance. During this webinar, we would be talking about fire detection in a prison or correctional facilities and in museums. Then we shall have a look at case study pertaining to the correctional facility, followed by a question and answer session.
So welcome everybody. My name is Zeno Nicolis and I work as a support engineer for Security International.
My name is Zacharias Almeida, responsible for sales in the EMEA region. During this webinar, we will be talking on how to apply our products to prison and museum application. We were approached by our clients and were asked to plan and design and to come up with a solution for fire protection in challenging environments, which are prison cells and a museum. After carefully studying the project, we came up with proposals and presented them to our clients, which resulted in a successful project application. Let's start by looking at a very special application, fire detection inside prisons, and in particular, inside prison cells using our aspiration smoke detection systems.
Well, protecting prison cells with a fire detection system might seem easy enough, considering the shape and size of the room. However, there are other very important aspects that must be considered, which make it a little less easy. So being security in cells, all systems implemented inside must simultaneously guarantee both a certain level of safety for the occupants for actual or induced fire events, and a certain level of security against possible vandalism. To achieve this, the installation and/or system must be as non-visible as possible or difficult to reach, and in any case, mechanically resistant to vandalism. For these and other reasons, we believe that the best solution for prison cells protection is ASD systems. In this picture, we can see an example of an installation with unreachable aspirating holes in the normal or vandal-proof steel version. In this other picture, we can see an example of an installation with aspirating holes inside the cell and protected by a metal grid. In this other picture, we can see an example of installation with pipes inside concrete or plasterboard using special accessory we have in our catalog. In this other picture, we can see an example of installation directly on ventilation return ducts. We can use a single ASD unit to protect multiple cells, or we can use a single SD in combination with our array key 511 pipe detector for single cell identification. Here we present a prisoner cell protection project we have developed with one of our customers. The request was to protect 7 cells, each with its own ASD 532. The designer's idea was to install the ASD 532 unit outside each cell and to enter with aspirating and exhaust pipe inside the cell. The idea of monitoring the air inside the air conditioning intake duct was also considered, but in the end, the designer preferred to make an aspiration directly into the room. So we considered using our piping system and accessory inside the concrete, but unfortunately, for installation reasons, there was not enough space to do so. So we had to think of an alternative solution. At the end, we propose to use our 25 millimeter flexible pipe, you can see here in gray, or the normal 25 millimeter rigid pipe with a 90-degree elbow and a vandal-proof aspirating hole.
We will now start the mid-break question and answers. The first question is, for detection inside the cell with an ASD system, is it necessary to also use the recirculation pipe?
Well, it depends. If the air pressure of the cell and the room where the SD is installed is the same, it is not necessary. However, it is advisable to use it if we want to avoid generating alarms, also in the room where the SD is installed.
Is it necessary to go inside the cell to do ordinary maintenance on the ASD system?
No, not for the ordinary maintenance. It is not necessary because it is possible to perform both pipe cleaning and fire testing from the outside using a test sampling hole on the pipe. And this is a very important aspect because maintenance in the prison is otherwise is very difficult.
So the next question is, can I use a single ASD to protect several cells?
Yes, it is possible within the limits allowed by the fire zone. So limits on maximum zone size, number of rooms, etc. But here you have to see your specific local regulation for that. In all the cases where it is necessary to detect a single cells, you can use REK 511 pipe mounted detector.
Okay, thank you. Here we talk about a special application in a museum, which was also very challenging. So this is our next application that we've done.
Yeah, in this application, the customer needs protection for both the under roof area that you can see in this picture and the museum interior. So, but we have to talk about an environmental characteristic because in the attic, in the greenhouse, we have a very high day, night, and summer, winter temperature fluctuations. We also have a high luminosity. We got high air recirculation for cooling or heating with an air extraction system. For indoor museum, we got a problem of installation and aesthetic problems. So you can see in this picture, they tried in the past to install a point detector, a smoke point detector, but the system has always given problems to them. So in order to better understand the situation, we organized a meeting with the museum technical manager, and we asked for more data about the temperature involved, particularly for the attic area, the greenhouse. So what you can see in this picture is a recording of temperature made in July, showing a temperature deviation over the course of the day during the 12 hours up to 28 degrees. Even in August, the temperature variation is very high with the maximum peak of 50 degrees. In this other picture, we got a situation in January, also with the relative humidity values. Another picture of a situation in June, also with the relative humidity values. So the conclusion of these meetings was like, we have to exclude the solution with spot detectors, which have already given problems for different reasons, high temperatures, big air exchange, humidity in the greenhouse, and aesthetic and maintenance problem inside the museum. So then we also exclude the solution with beam detectors due to the high solar radiation, so that can cause false alarms, high temperature, high air exchange that cause dilution, interferences with the metallic beams, we have seen the picture, and maintenance difficulties. So for all these reasons, we propose a solution with ASD aspirating system. One for each greenhouse zone. The museum was quite big and configured in class A or B because dilution, we need to have more sensitivity. And one ASD for each zone inside the museum, configured in class C, so normal sensitivity, and using capillaries. So as you can see in this picture, the technical specification of the ASDs 535, the parameter of a temperature, relative humidity, etc., are compatible to work in this application. Also, in order to avoid the possible condensation problems, we have suggested the use of accessory that we will see later on in the next slide. But particularly attention must be paid for the greenhouse to the temperature deviation that is greater than 20 degrees, which can lead to airflow variation on the ASD system and thus to fault signals. So to avoid this problem, in addition to changing the airflow settings, we have suggested an airflow calibration at an ambient temperature of 35 degrees. So in these pictures, we can see a radiator cooling system and a condenser for humidity. These two accessories we suggest to use to protect the greenhouse in combination. So here we see a design example of the SD installed in the greenhouse with the 10 holes and with the calculation of the parameter at 20 degrees of temperature. So under this condition, we have an air pressure of the pipe of 223 Pascal and an airflow rate of 1.18 liter per second. This is the same design, but calculated at 50 degrees. That is the peak of temperature reached in August. As you can see, the parameter of pressure and airflow, they changed. So we got a pressure of 205 Pascal and airflow rate of 1.13 liter per second. So that means that we got a difference of 4% and 8% respectively for airflow and pressure when going from a temperature of 20 degrees to a temperature of 50 degrees. So to compensate this fluctuation, we suggest, if possible, calibrating the airflow at a temperature around 35 degrees and setting the flow failure threshold on the ASDs to plus minus 50%.
Now let us look at the case study, correctional facilities. This case study gives you in-depth info on how, what, why, when scenarios. This case study is about the fire detection challenges in such an environment. Fire detection required for various areas within a correctional facility. Multiple security layers require situational awareness to be effective. Fire prevention and orderly response to emergency are critical design considerations to achieve life safety objectives. Risk in and around the secured and confined prison cells present challenges to smoke detection. Fire can cause deaths, unacceptable loss, and interrupting facility operation. If a fire originating from an isolated cell or areas behind multiple layers of physical security barriers is detected too late or encountered with inadequate response measures, the risk to life and resulting property can be substantial. In addition to the damage as such, a fire is likely to jeopardize facility operation continuity and orderly managing the evacuation of high risk and often dangerous inmates to a place of safety. The use of an early warning fire detection system represents significant advantages over conventional detection methods. A well-designed and reliable early warning fire detection system provides risk mitigation to potentially prevent a fire from happening or developing out of control. The protection of correctional facilities is important for life safety because of the unique building occupancy, associated operational needs, and higher degree of complexity in the event of an emergency evacuation. For better risk management and fire protection in such facilities, preventing a potential fire at its incipient stage is paramount to business operation continuity. So this case study can be downloaded from our partner data. So if you don't have partner data access, you might contact your area sales manager and he will send it to you. Here are some references from left to right. We see a prison in the United Kingdom. Then there's a prison in Mexico in the middle, a museum in Mexico on the far right. Then we have a museum in Switzerland, a museum in Egypt, and a carpet museum in Mashhad, Iran. We will now start answering any questions you may have. So some questions that I have is, in the example we saw, the temperatures inside the greenhouse are very high in summer. Up to how many degrees can I use plastic pipes or ABS pipes?
Well, ABS pipes can work at the maximum temperature of 70 degrees. However, certain precaution must be taken at high temperatures. So you must consider fixing the pipe every 60 centimeters and provide for possible elongation. Also, sunlight will also be a problem and has to be taken into account, because when it is very intense, it will damage the pipe due to the UV radiation. So alternatively, metal pipes can be used.
The next question is, for ordinary maintenance, do I have to test all individual sampling holes with smoke every time?
No. It is sufficient to test the first sampling holes for each pipe or and branch. So that is enough.
The next question is, if I need to use many ASD units for the protection of the museum, is there a possibility of connecting them together so that they can be managed from a single point?
Yes, it is possible in two different ways. So you can connect them through each other using RS485 serial cable, or you can connect them together using Ethernet TCP/IP network. It depends of the ASD model used.
The next question is, the radiator has to be extended all the way along the piping or just in the section next to ASD control unit?
Normally, is only necessary to install it next to the ASDs. So we use it to cooling down the temperature, so it has to be like close to the SD unit.
And the last question is, can you repeat how many holes we need to test during maintenance?
Yeah, normally you just need to test only the first sampling holes for every pipe or branch.
Thank you, Zeno, for the answers.
Welcome.
Please follow us on LinkedIn and Instagram channels, where we have the new information on design guides and case studies, and also other information regarding our business. So please follow us on LinkedIn and also subscribe to our Instagram channel.